Start, sir.
Sir, we can start our class.
Okay, fine. Good morning, everyone. Today, we shall discuss the topic binomial theorem, chapter 6 from 2A. 2A, chapter 6, binomial theorem. First, we shall define what a binomial is. Binomial means two terms connected. Two terms connected by either plus or minus. So binomial means two terms connected by either plus or minus. So we have come across many explanations or expansions of squares, cubes, etc. of a binomial in earlier classes. We have come across about expansions of squares, cubes, and all these in the previous classes. For example, x plus y whole to the power of 1 is equals to x plus y. X minus y whole to the power of 1 is equals to x minus y. We'll see x plus y whole square is equals to x square plus 2xy plus y square. And again, x minus y whole square is equals to x square minus 2xy plus y square. We'll see a few more expansions. X plus y whole cube is equals to x cube plus 3x square y plus 3x y square plus y cube, and also x minus y whole cube is equals to x cube minus 3x square y plus 3xy square minus y cube. X plus y whole to the power of 4 can be written as x to the power of 4 plus 4x cube y plus 6 x square y square plus 4 xy cube plus y to the power of 4. So each of these, if you look at this one, each of these, the previous expansions also, each of these expansions of power or of sum or difference of two terms If you look at this one, each of these is an expansion. Each of these is an expansion of power of sum or difference of two terms. So now these expansions are called binomial expansions. If you look at this one, the coefficients. What are the coefficients? The coefficients 1, 1 in the expansion of x plus y whole power 1. We have 1, 2, 1 in the expansion of x plus y whole square, and we have 1, 3, 3, 1 in the expansion of x plus y whole cube, and we have 1, 4, 6, 4, 1 in the expansion of x plus y whole to the power of x plus y whole to the power of 4, etc. Are called binomial coefficients. These are called binomial coefficients. So now if you look at this one, these, if you look at this one, 4, 6, 4, and when you have 1 and you have 1, these coefficients, isn't it? You have 1 and 1. Is this clear? Look at this one. These are coefficients in the expansion of x plus y whole power 4. And if you look at this one, 3, 3, and then you have 1 here and 1. So these are the coefficients, also known as binomial coefficients. These are called as binomial coefficients. These are also called as binomial coefficients. Okay. From the example, we observe that the coefficients in these expansions are as follows. So let us write in a form of table. If you look at this one, first we'll write index, and then we'll write coefficients here. So if the index is 1, we'll see we have 1 and 1. So we'll draw in form of triangles, and then first we'll form this one. So 1 plus 1, 1 plus 1 is 2, and then we'll write 1 and 1 here, and this will be, first let us draw this one, and then I'll explain you in detail. This will be 3 and this will be 3, and you have 1 and 1 on the either side, and then draw again the triangles. So this will be 4, 6 and 4, and 1 and 1 on each end, and again we'll do one more. We have 5, 10, 10, 5 and 1 on each side, and so on. Let us see the index of this one. First it is for the index 1, and then it is for the index 2, and it is for the index 3, and then 4, and then 5, and then so on. So now from the above diagram, or from this diagram, what do you observe? We shall write those steps. Look at this one carefully. From these diagrams, from the diagram, we observe, first point, each row begins and ends with 1. So what do you observe from the diagram? Each row begins and ends with 1. We'll see the next point. Second point, the other numbers except for the first and last, except for the first and last, the other numbers in a row are obtained by adding the two numbers in the previous, by adding the two numbers in the previous row on either side of it. This addition is shown by means of the triangle in each row as follows. If you look at the triangle what we made, we have A and B, and the resultant was A plus B. A plus B. If you look at the second point, we shall discuss the second point. The other numbers, isn't it? What are the other numbers? The other numbers in a row. The other numbers in a row are obtained by adding 1 plus 1, you get 2. 1 plus 2, you get 3. 1 plus 3, you get 4. 1 plus 4, 5. 4 plus 6, 10. 3 plus 3, 6. So this way, by adding the two numbers in the previous row on either side of it. isn't it? So this addition is shown by means of a triangle in each row this way, A plus B. You get the resultant as A plus B. And this triangle is called as, this diagram is called as Pascal triangle. This diagram is called as Pascal triangle. So this diagram is called as Pascal triangle. Okay. Now we'll get on to the next point. The expansion of x plus y whole to the power of n using multiplication becomes, this expansion becomes difficult as n increases, as n increases. In this chapter, we derive the expansion x plus y whole power n when n is a positive integer, n is a positive integer. This result is known as binomial theorem. This result is known as binomial theorem. We derive the expansion x plus y whole power n where n is a positive integer, and this result is known as binomial theorem. The coefficients of the terms, x to the power of I, y to the power of j are called binomial coefficients. Next point, we shall discuss next point. In the expansions of x plus y whole power n, we observe the following. We observe the following points. So we'll discuss in terms of points. Okay. What's the first point? As we proceed from left to right, the index of x, decreases and the index of y increases by 1 at a time. So let us see the second point. The coefficients in the expansion of x plus y whole power 1 are 1c0 and 1c1, and in the expansion x plus y whole square are 2c0, 2c1 and 2c2. And if you look at the expansion x plus y whole cube, what are the coefficients? 3c0, 3c1, 3c2 and 3c3. And let us see the coefficients of x plus y whole power 4. What are the coefficients of x plus y whole power 4? 4c0, 4c1, 4c2, 4c3 and 4c4. So from these observations, we can easily guess the general formula for the expansion x plus y whole power n, okay, for any positive integer n. So from these observations, we can easily guess the general formula. Okay. Now let n be a positive integer. Let n be a positive integer and x comma a be real numbers. Then x plus a whole power n is equals to nc0. This is very important expansion. Just try to concentrate. X to the power of n, a to the power of n, sorry, a to the power of 0 plus nc1, x to the power of n minus 1, a to the power of 1 plus nc2, x to the power of n minus 2, a square plus so on plus ncr, x to the power of n minus r into a to the power of r plus so on plus ncn, x to the power of 0, a to the power of n. So in the expansion, So in this expansion, NC0, NC1, NC2 are called binomial coefficients. And they are simply denoted as denoted by C0, C1, C2, so on Cn. Okay. Now we shall see how we can reduce this expansion in terms of a summation formula, and we'll see how many number of terms are there in this expansion. Suppose let n be a positive integer and x comma a be real numbers, then x plus a whole power n can be written in the summation form as sigma r is equals to 0 to n ncr into x to the power of n minus r into a to the power of r. We shall see summation means it's the addition of terms. We shall see if you take r is equal to 0, what is the term you're getting? If you take r is equals to 0, 0, 1, 2, so on till n. So you're getting NC1, NC0, NCR, x to the power of n minus 0 into a to the power of 0, which is nothing but first term NC0 x to the power of n, a to the power of 0. If you take r is equals to 1, what do you get? NC1 x to the power of n minus 1, a to the power of 1, which is NC1 remains the same, x to the power of n minus 1, a to the power of 1, so on. Suppose if we see r is equals to n, take the term n, last term. So what will it be? NC n x to the power of n minus n, a to the power of n. So this will be NCn x to the power of 0, a to the power of n. So if you look at the expansion, what we define, NC0 x to the power of n, a to the power of 0, NC1 x to the power of n minus 1, a to the power of n, and last term NCn x to the power of 0, a to the power of n. So in a similar manner, we can simplify these summation, and we can write x plus a whole power n in the form of summation like this. We shall discuss the next point. We shall see the second point. The expansion of x plus a whole power n has n plus 1 terms. Okay, and we shall also define what the general term is. What the general term is. General term. In the expansion, of x plus a whole power n, the r plus 1 term, is called the general term. Is called the general term and is given by tr plus 1 is equals to ncr into x to the power of n minus r into a to the power of r for 0 is less than or equal to r is less than or equal to n. So if you look at this one, this is the general term. If you look at the expansion where we have done, this is going to be the general term in the expansion. And now we shall see one more expansion. So the general term is this one, tr plus 1, r plus 1 term is the general term in the expansion, x plus a whole power n, and tr plus 1 is given by ncr x to the power of n minus r into a to the power of r. So we shall see one more expansion based on x plus a whole power n. We know that x plus a whole power n is equals to, we've already expanded this, nc0 x to the power of n a to the power of 0 plus nc1 x to the power of n minus 1 a to the power of 1 plus nc2 x to the power of n minus 2 a square plus so on plus ncr x to the power of n minus r a to the power of r plus so on plus nc n x to the power of 0 a to the power of n. So we've already defined this one and derived this, or we have expanded this x plus a whole power n. Now on replacing a by minus a by minus a in the expansion x plus a whole power n, we'll see what do we get. So this is written as x minus a whole power n. We are replacing plus a with minus a. We'll see what are we going to get. So this can be written as nc0 x to the power of n. A is written as or replaced by minus a whole power 0 plus nc1 x to the power of n minus 1 minus a whole power 1 plus nc2 x to the power of n minus 2 into minus a whole square plus so on plus NCR x to the power of n minus r into minus a whole power r plus so on plus NCN x to the power of 0 minus a whole power n. So now we'll expand this one. We can also write this as minus a whole power 0 is a power 0 itself. So NC0 x power n a power 0, and this term will become minus a. So this term can be written as minus NC1 x to the power of n minus 1 into a to the power of 1, and minus a whole square will become a square, positive. Minus 1 whole square is positive. Minus 1 whole square is positive. So this can be written as plus NC2 x to the power of n minus 2 a square plus so on plus minus 1 whole to the power of r. Here, what do we have? Minus a whole to the power of r, isn't it? Minus a whole to the power of r. What can you write? This is nothing but minus 1 into a whole to the power of r. This is nothing but minus 1 whole to the power of r into a to the power of r. So minus 1 whole to the power of r I am writing in the starting. So this can be written as minus 1 whole to the power of r NCR x to the power of n minus r into a to the power of r plus so on plus, similarly we can write this as minus 1 whole to the power of n into NCN x to the power of 0 a to the power of n. So this is how you expand x minus a whole power n. We already have x plus a whole power n. We are replacing a with minus a. So what is the general term here? What is the general term you observe? This is going to be the general term. So this is what the general term. General term. In the expansion, x minus a whole power n. In the expansion, x minus a whole power n, minus 1 whole to the power of r NCR x to the power of n minus r a to the power of r is the general term in the expansion, x minus a whole to the power of r. Now we shall do one problem based on this one, on this expansion. Let us take down. Let us consider this as first problem. Expand four x plus 5y whole power 7 using binomial theorem. Using binomial theorem. Okay, this is how the question is framed. So now we'll see the solution. We know that, again, the same expansion. I'll write once more, try to practice this one. X plus a whole power n, based on this expansion, we can expand 4x plus 5y whole power 7. So first we'll write the formula or the expansion of this one. You know that x plus a whole power n is nc0 x to the power of n into a to the power of 0 plus nc1 x to the power of n minus 1 a to the power of 1 plus nc2 x to the power of n minus 2 a square plus so on plus ncr x to the power of n minus r, a to the power of r, plus so on. NCN, x to the power of 0 and a to the power of n. Based on this expansion, we shall expand 4x plus 5y whole power 7. This can be written as 7c0 4x whole power 7 into 5y whole power 0 plus 7c1 4x whole power 6 5y whole power 1. The x term will be decreasing and the y term will be increasing. How did you get this one? You got this one as 4x whole power n minus 1, isn't it? 7 minus 1. So which is nothing but 4x whole power 6. You can write directly. We're writing 4x whole power 6. And we'll write the next terms. Plus 7c2 4x will decrease 5 into 5y whole square. X term will decrease and y term will increase. It will become 5 and this will become 2 plus 7c3 4x whole power 4 and then 5y whole cube plus 7c4 4x whole cube 5y whole power 4 plus 7c5 whole 4x whole square into 5y whole power 5 plus 7c6. What is that? 4x whole power 1 into 5y whole power 6 plus 7c7 4x whole power 0 into 5y whole power 7. So this can all be written, also be written as summation of r is equals to 0 to 7. R is equal to 0 to 7. 7cr 4x whole power 7 minus r into 5y whole power r. This is how you're going to expand this one, isn't it? If you look at the terms, how many terms are there? 1, 2, 3, 4, 5, 6, 7, 8. So n is 7. You will be having n plus 1 terms. Here we have n is equals to 7. We'll have n plus 1 terms. We have 8 terms. So you have to remember this one. So let us take the assignment for today. Today's assignment. Expand the following using binomial theorem. First bit. (2p by 5 minus 3q by 7 whole power 6. We'll take one more bit. 2a plus 3b whole power 6. So try to simplify this. Go through the expansion and go through the general term, whatever we've discussed in this class. Okay. and try to complete the assignment. Okay. Thank you, madam. Thank you, sir.
Thank you, sir.